Thank you so much for being here today. And Director Walker, we have a special Centennial Park grant update and a special guest. Would you also like to introduce her? Or Caroline would. Thank you.
Hi, good morning, everybody. Yes, so we've got Amanda Trianens with Cultural Heritage Conservation LLC. They're based out of New York City. Amanda is going to be presenting information from the Centennial Park Parthenon Historic Concrete Structures grant that we got from the Tennessee Historical Commission. I would like to note Claudette Stager, the Deputy Chapeau of the THC, is on the call, so we want to thank her for attending the presentation. And Amanda is going to walk us through. I also want to note that the project was funded with matching funds from the Centennial Park Conservancy. So Amanda?
Thank you for the introduction. It's nice to be here today. I'm sorry I can't see any of your faces. But I'm going to give a sort of quick, it was a very dense study, but I'll give a quick synopsis of the methods and findings. The project was the conservation needs assessment for the Parthenon and historic concrete structures at Centennial Park. I'm an architecture conservator and owner of Cultural Heritage Conservation. I have a specialty in concrete. I also do work in stone, mortar, stucco, brick, terracotta. I teamed up with Silman for preservation engineering. We've worked together for many years. Our very first project ever together was the Guggenheim Museum in New York City. I also teamed up with Schnabel Conservation for the petrographic analysis and Allegroni Companies for the cost estimates. So I think Carolyn just mentioned the project was able to happen because of a grant from the Tennessee Historical Commission and added funding from the Centennial Park Conservancy. And so the scope of work, the scope of work focused on the Parthenon and 4 concrete structures at Centennial Park. And there are others, but the RFQ was specific to these monuments. So the scope of work included conditions assessment, which is usually a visual examination, recommendations for maintenance and repair, prioritizing those repairs. So for instance, if it has to do with public safety hazards or potential loss of historic fabric, those would be a high priority repair. Cost estimates for the repairs recommended or monitoring and maintenance. And then for the 4 structures, excluding the Parthenon, we did materials analyses for the concrete mix compositions. The Parthenon was excluded from that because it was extensively researched in the early 2000s. I incorporated a few other assessment techniques, drone photography, because we couldn't get to the roof and some of the cornice of the Parthenon, sounding, which detects voids and delaminations in materials, moisture meters, rebar locating, and biofilm removal tests. So this scope of work, we were awarded the project in June, and the deliverable was due on the 30th. So I'll start with the Parthenon. I mean, there's just an incredible amount of information on the Parthenon, so I'll just sort of keep it quite narrow at some of our findings. Just briefly, this is the building you see today is a 1920s, open to the public, 1931 structure. It is a replica of the Parthenon in Athens. However, this is a reconstruction. The original, as probably you all know, was built in 1897 for the Centennial Exposition. It was built of temporary materials, so plaster, staff, and was quickly deteriorating. So they decided to reconstruct it. Some elements are extant from the 1897 version, but they commissioned John J. Early to do the exterior concrete, and he was an artisan known for architectural concrete, exposed aggregate panels, this polychromy that you see at the pediments and frieze, and then this very sculptural, using concrete in this very sculptural manner. So it's just an exquisite example of his work. So we were charged The first site visit we had there, I met with stakeholders, and largely the charge of this scope was to review the repairs from the early 2000 restoration campaign, just to see how they're doing, which is a great best practice approach for concrete. Well, all historic structures. And then there were some concerns of cracking and tripping hazards at the porch steps and floor. So we sort of focused on those areas. We sort of broke the building down into sections, and that's how in our report, and that's how I'll present them here. Largely, I'm sort of skipping the roof to the goutte elements just because those were largely in good condition, just a couple misplaced tiles or displaced tiles. So then sort of the next sort of group of architectural elements on the building is the architrave to the column capitals. What we found there was a lot of cracking. We do know there was work there in the early 2000s done, and we see some of those repairs. Some of those are sound. Some of those are separating from the historic concrete. There are some cracks in them. There's some new cracks here. If you can see, it's sort of very faint. I mean, it looks like a hairline crack from here, but as you get closer, it's a little bit wider, and you can see some of them coming out from these repairs here. What happens is if you start to get all this cracking that becomes sort of like a network, you create these sort of islands of concrete that at that overhead configuration are a public safety issue. So that is one area that does need some attention. Working our way further down the building, we looked at the building walls. If you were to take away these sort of, these columns in front, there's the building walls sort of deep in the porch. This is just a quick field note sketch on the bottom right of basically looking at the cracks, just quickly mapping sort of their shape and somewhat their extent to see if we can see patterns. You can see some of the cracks here on the left that we're seeing on the building walls. Largely, it does not appear that they allow moisture or driving rain, again, because of the depth of that porch. But this has been an ongoing issue. The earliest archival data we have for research on the building was the 1960s, and already cracks were being seen and mapped then. And then lastly, again, looking at the porch steps and porch floor, a lot of cracks, though there is, you can see in this left photo, there's this sort of pinkish fill. That's a caulk that we think is from the early 2000s. So it has definitely, its lifespan is over, and in some parts it's still functioning. But it's no surprise that we're seeing a lot of the caulk failing. Also on the left photo, you can see sort of what happens if the caulk starts to fail. Pieces of concrete come up, and again, those are tripping hazards at those locations. The middle photo, it's a little harder to see in this photo because it doesn't have the pink caulk in it, but those are cracks there that have not been filled. And then on the right, we looked quickly at the basement level just to look at some of the structural elements there. So how we tiered the repairs, we gave some options for some of the repairs. So you can do, for instance, on this porch level, you can remove the caulking and replace it. And where there hasn't been caulk, you open up those cracks and you install more caulk. I think one of the issues is that this is an ongoing condition. It's been noted throughout the building since the 1960s. So some of the recommendations in the other tiers of options for repair are long-term monitoring. So why is this building cracking? We do know these steps are on grade. They're not on the foundation. So we know there must be some sort of settlement going on, maybe differential movement. Some of the cracks, if we do monitoring, is it seasonal? Is it moisture related, temperature, both? And how would we address that? So some of the long-term monitoring would try to determine cause of cracking to try to more holistically address some of the conditions that we're seeing. So that was sort of briefly and broadly the recommendations for the Parthenon. So moving on to the other 4 structures that we looked at, I'm going somewhat in chronological order. This monument is called Shell Spring. We refer to it sort of as an architectural folly. So it's almost more about the form than it is the function. Though we do think it served a function. There was a spring that ran underneath it. There are benches inside. There's this tiered limestone where you could sit and sort of enjoy the spring. The photo on the left is from an annual report of the park in 1912, and you can see a lot of the details there, some of those coping details that are largely gone now. So the picture on the right is the same view a little bit further back today. And that's the engineer in the back, just to give you some sense of scale. And what we found was just through visual assessment and then petrographic analysis confirm this. It's almost more like a mortar. So this is a 1906 structure. So it's very early reinforced concrete, and it doesn't have that large aggregate. So it is almost more like a mortar than it is a concrete. And one of the biggest questions for us is, how is this cantilever? So this is, looking into that clamshell area. And this is what I was referring to, if you can see my arrow, for some of the limestone where you could be seated. And there was lighting here. But how is this cantilever being supported? We have these posts here that you can see in this right photograph. There's one on either side. Is that the only support, or what is that subsurface foundation of this clamshell like? So the recommendation here would be to do some test pits, some excavation to see what's going on and to make sure it's structurally sound before we start doing some of the other repairs. You can see here, there's some of the cracks and areas of loss on these retaining walls as well. This is the backside of the shell. So this would be sort of the north, we're looking south here. So again, this area, the grassy area, we'd want to do a little bit of exploration there. It was poured in a couple lifts. So we have some areas where lifts of concrete or mortar have displaced. We have areas of loss here. And then this is a little bit closer view of the interior. You see a lot of this debris. It's actually chunks of the concrete. So there does need to be some intervention happen before we lose an even more significant amount of the historic concrete. And then we also do have some past interventions that aren't necessarily helping or working, maybe never did. This is something we see very commonly, is these coatings that go on. If you can see my arrow here, it's some sort of elastomeric coating that was applied, but really what it's doing, the earth is on the backside of that retaining wall and this thick elastomeric coating's on the front, and it's just trapping moisture in that historic concrete. So removing some of those and assessing what we have underneath is also imperative. We do know it's reinforced concrete. If I can go back a photo here. So we do have the conduit for the lighting, but what we also see is reinforcement, steel reinforcement, and it's this square bar with ridges in it. But interestingly, we also have a rebar design here that's a smooth round bar, which is not ideal for the concrete in the sense that there's no mechanical key for it to hold on to. So we do see areas of loss in this location, and then that same rebar design, though we saw it in one of the ribs of the clamshell, we see it in the front here, just showing you this area of loss at that lip of that clamshell. And we suspect that that rebar goes through, and we see cracking. So there again, there's this imminent loss at the clamshell here as well. Some of the questions we posed in the report are, as far as this wall here on the left, it's maybe less the centerpiece. It's not the clamshell. Do we re-pour it, or do we restore it? If it needs more structural enhancement? Do we sort of do a buttress subgrade so we hide that addition? Do we reintroduce the coping? So there's a lot of questions to consider on how to go forward. Some of those, are philosophical, like how do you want to go about this? Some of them are budget, what if we choose this route or this route, and how do we address the needs, and how much of the historic material do we want to preserve? So excuse me, the next structure we looked at is the bridge at Lick Branch Sewer. Again, historic photo on the left. We believe this one was built in 1907. It was designed by Wilbur Creighton Sr. of Foster and Creighton Company. What it said in archives is this was their first experience with reinforced concrete. Here you can see the arch of the bridge, whereas today this is the same view looking east, and the arch is now backfilled. But what we do have remaining is the railing and the posts. And it has been reparged. Parging is like stucco. And we think there might have been some original parging. What we see today is largely recent, or not original. We think there's a couple layers of different parging coats applied through the years. So some of the approach here, if we zoom in on details, to a large extent, it's in okay condition and we can preserve this the way it is. And we're not looking at historic concrete, we are looking at this more recent parge. However, if we remove that parge, we potentially remove a lot of historic concrete with it. So that's a consideration of how to proceed. But there are about maybe 12 balusters that look like this. Well, not quite this bad. This is the one in worse condition, but about 12 that need some sort of injection, repair, patching, consolidation, and then some of the posts do as well. And one thing about the bridge site, and you'll see this in the next structure as well, is there, and actually this goes for all four of the concrete structures, some sort of rethinking of the site, how can we get water off of the base of the concrete? The concrete used to be thought of as permanent, and we know it's not, especially when it's early 1900s. It's quite soft and not as endurant as we know today, just because of manufacturing abilities back then were very different. So maybe rethinking, do we do some sort of drainage, or how do we let water shed away from the historic fabric? Next, the 1910 concrete bridge. So this one's also by Creighton, but archives say this is one of the company's first reinforced concrete bridges. So again, a little bit later than bridge at Lick Branch Sewer. So again, 1912 photo, so somewhat shortly after construction on the left. On the right, that's not the same view. That's how it looks today. This is the east elevation of the bridge. And you can see that we see the arch on this side. The arch is buried on the west elevation. But some of the concern we have at this bridge is, well, it's stuff we couldn't really see. It's sort of, the parts underneath the arch that we couldn't get to. We have some, the parging again is gone. There's some exposed rebar. We see that at the edge of the bridge here on the left. And that's some of those areas that you see. It's sort of hard to get a photo in there, or a camera in there to take a photo, but we would recommend doing a little bit more investigation of that underside of the bridge. Otherwise, here I think we actually have potentially some original parging. We do have later repairs as well. Here you can see that later repair just has a very different visual to it. This is, if you can see my arrow, this sort of lighter area is original, and this darker rusty sort of gray color is newer sort of repairs. But here you can see across the railings we have several of cracks like this. Here you can see where the parging is and where the exposed concrete is. So and cleaning some of this biogrowth, reintroducing parging, filling in and patching concrete where necessary. So for instance, here, some of the concrete is gone as well, not just the parging. So some of that is very basic, typical concrete repairs. And then again, the consideration of, you know, the blacktop goes all the way to the concrete. Is there some other way we can think about having the water run off from the historic concrete? And then lastly, Gunboat, Tennessee Memorial. On the left, this is a photo, again, of 1912. We think it was built in 1910, and it was built to exhibit this bronze figurehead. That was a cast for the U.S. cruiser Tennessee. So that's this bronze figure in the front. There's some accounts that say that maybe it was gilded. I didn't see any physical evidence of that, but I wasn't looking under magnification. But here you can see in 1912, we have a canopy, a flagpole, some lighting. Here it's a little bit harder to see. There were chains coming out of the portholes. We presume there's some sort of maybe anchor attached to them, and all those elements are no longer there today. So this is the same view today. Here is the south elevation of the monument. There is a lot of the parging is failing, so you can see here it's fallen off and it's exposed the concrete. We have cold joints, and what those are sort of the joints that happen between pores of concrete. So there's one here and there's one here, but we also have cracking. So the recommendation would be to remove the figurehead, have that restored separately. That has to be done carefully. There are these sort of rusty bolts bolting it to the concrete. The parging should be removed. There'd have to be some care at the top. It seems like certainly a later addition of parging at the top that could be very well adhered, so that would have to be done sort of cautiously. Restore the concrete as required, and then reparge and reinstall the figurehead. But then there's a couple other issues. So this is the west elevation. There are stairs that go to the top. Presumably there were originally. We don't have an archival photo of that angle, but in that historic photograph, there was a man on top. And there's a doorway, which leads, well, the stairs lead to the photo up on the left, to the sort of what we've been calling the roof of the monument. And the structure is hollow. So this is the interior at the upper right. So the concern we have for the gunboat is these I-beams. So one has completely fallen. There's two I-beams that go the length of the gunboat. And one is completely fallen and one is significantly corroded. What we don't know is if those I-beams were to support the concrete roof, or if they were there for formwork purposes for the construction of the monument. So we'd need to dig into that a little bit deeper, maybe do some probes, and get a sense of how necessary these I-beams are. One of our recommendations was to maybe remove the back stair and not allow anyone up there because of public safety hazards. We don't know what's happening here. We don't know if we need these I-beams. And this lower photo is all the exposed rebar in the concrete. So concrete works really well in compression. It doesn't work so well in tensile strength. So that's where the steel comes in. But the steel, once it corrodes, of course, so we've lost all this concrete over the rebar. And so that would need to be, the rebar would need to be cleaned, coated, and concrete reintroduced at these locations. But we think this rebar corresponds potentially, if you can see it, they're somewhat hard to see, but these cracks in the roof of the gunboat. Just so to understand those patterns, to understand the condition of the rebar and the necessity of those I-beams is recommended. And just a last photo, a couple photos of close-ups of the exterior. Again, there's that cold joint, but in that cold joint, you see sort of fragments of concrete, scaling. We see the loss of the parge coat, this crack at the parge coat. That's where the walls meet the roof line. And here we have sort of more dimensional loss of concrete that would need to be reintroduced to, you know, sort of have that architectural element back. And again, the removal of the figurehead. Some of these bolts are buried under something, so those would need to be dug out. And there's these iron pins that would need to be removed in order to remove the figurehead. So that is the speed version of our findings. And I just wanted to open it up to any questions if anyone has any. So thank you for your time.
That was so interesting. Thank you so much. I have a question. Parging, that's a new word for me today.
I was going to ask the same thing.
Yeah, so it also can be called stucco or render, but it is just that. It's this sort of thin stucco-like coating on top of concrete. And, you know, concrete, once you remove the formwork, it can have a lot of inconsistencies in it. So I do believe there's likely an original parge coat, that sort of like, again, this like stucco coat that kind of made a cohesive visual appearance on, well, a lot of these structures. Shell spring, that's a little bit, I'm not so certain about, but I do believe there is one on the two bridges and Gunboat.
Thank you. Anybody else? Question?
A quick question, Amanda, thank you for your presentation. Tom Wood here. I'm surprised that I think all of these concrete structures are from the early 20th century. Is there nothing left from 1897 on the site?
You know, I don't believe so, though. I think Caroline could actually answer that better. I don't think there's anything from the Centennial Exposition.
Yeah, that's correct. The Parthenon was the only standing thing until it was reconstructed.
So Centennial Park has a remarkable inventory of early concrete. It's just dreamy.
Thank you so much. I've learned more than I couldn't even comprehend that. So thank you for all of your work on that. And Caroline, thank you for all of your work on that. That's obviously, by looking at the pictures, something that is desperately needed to be done. So thank you all for that.